What are flux and intensity? Well, I'm going to consider 4 different kinds of quantity here. Amount, amount per time, amount per area, and amount per area per time. Now this is generally called the intensity, and flux, unfortunately, means different things in different areas. We have particle flux, light flux, electric flux, magnetic flux, heat flux, and so on. And different disciplines use the word flux differently. So I'll run through a few examples. Let's take people. The amount is the number of people. Amount per time would be something like the birth rate, how many more people you get per year. The amount per area would be like the population per square mile, the population density. And amount per area per time would be something like the birth rate per county. Here's another example. The amount might be the volume of snow from a snowstorm. Then the amount per time would be saying, how many cubic meters of snow are falling from this storm per hour. The amount per area would be the volume per area is actually the depth. How deep was the snow? We got 8 inches of snow, say. The amount per area per time was the rate of snowfall. How fast is it happening? How many inches per hour is the snow coming down? This would be what we call the intensity, and this might be what we call the total flux. The word flux is ambiguous. Sometimes they will refer to this, sometimes they'll refer to that. If they say total flux, they're usually talking about this kind of quantity, the amount per time. Electric flux and electric field are trickier. There isn't any fundamental stuff that I know of that would be measured in volt times meter times second, where flux would be the time rate of that. Electric flux is measured in volts times meter. And then electric field would be the flux divided by area, and so it would be volt per meter. The main thing to remember is that flux is field times area. So the field, which is also called field intensity, is flux over area. In fact, I've heard electric field referred to as the flux density. In the same way, we have magnetic field and magnetic flux. Again, there isn't any basic quantity of volt times second squared, unfortunately. And the main thing to remember is that magnetic flux is magnetic field times area. Magnetic field is measured in Teslas. A Tesla breaks down into a Newton per amp meter. Magnetic flux is, of course, that times square meters. A Tesla times a square meter is called a Weber. It's also a volt times a second. So magnetic flux per time would be in volts. Again, magnetic field is sometimes referred to as the magnetic field intensity or the magnetic flux density. Now, is there any kind of intuition we can have about magnetic field, magnetic flux, electric field, electric flux? If you think of magnetic field lines as swooping through space, you can think of an area as sort of catching some of the magnetic field, and the amount that you catch is the flux. Picture way is how many magnetic field lines did you capture would be the total flux, and the flux density would be how concentrated the field lines are. Likewise for electric field, that's as close as I can come to a visual analogy. Capital phi is often used as a symbol for flux, and we say phi sub b for magnetic flux or phi sub e for electric flux. And 2 of the Maxwell equations state that if you take a completely closed surface, the magnetic flux through the surface is 0, and the electric flux through the surface is proportional to the charge inside. The same mathematics was used for fluid flow, and you can almost imagine this as flows of water. Unfortunately, there's limits to how well that analogy works. Anyway, I hope this helped clarify a little bit the ideas of intensity and flux. Thanks for watching.